Hello, my name is John Sloan. I'm the Executive Vice President for NotSoSecure USA. I want to thank you for joining this exciting and extremely informative webinar, DevSecOps, What, Why, and How. Before we get into the heart of the presentation, I want to first highlight a little bit about who we are. NotSoSecure is an intricate part of our Claranet Cyber Security practice. Claranet, our parent company, is one of the largest managed service providers in Europe and abroad, focused on modernizing and running critical applications and infrastructure 24/7 for our customers. The Claranet Cybersecurity practice has over 20 years of experience in cybersecurity services and training for some of the biggest brands across the globe. We are one of the largest training partners of the globally acclaimed Black Hat Conference, where we train hundreds of participants in cybersecurity every year. What differentiates us from our competitors in cybersecurity is we hack and we teach. Our teachers are our hackers, enabling us to provide the most researched and capable penetration testers in the market. As teachers, our hacker training program encompasses training that supports beginners, which are individuals with little to no security experience, all the way up to advanced, to include advanced infrastructure hacking and advanced web hacking. We also have specialized cybersecurity training focused on AppSec for developers and hacking and securing cloud. This webinar is introductory to our two-day DevSecOps training course. At the end of the webinar, we will provide additional information on how and where you can attend our next course. As hackers, we provide white box and gray box penetration testing services for your business applications, infrastructure, cloud, and mobile environment. Additionally, we provide successful black box red team security assessments where we leverage our hacking expertise to find vulnerabilities that vulnerability scans are not able to identify. This wraps up a little bit about who we are. Now, without further ado, I welcome Abhijay Singh, who is going to give us unique hacker insight into our DevSecOps course. There will be a Q&A session at the end of the webinar. Please feel free to submit questions via chat throughout the session. We will gather all questions and present them back during Q&A. Also, we do have a prize draw to attend our next live delivery of DevSecOps training, which I will address at the end of the webinar. Abhijay?
Thank you, John, for the great initial start to the session. Again, a very warm welcome to each and every one of you. Welcome to our webinar on DevSecOps, automating security in DevOps. Now, before we begin with the webinar, a quick introduction about myself. So, myself, Abhijay Singh. I have been working with NotSoSecure for the past couple of years. And overall, I have more than 10 years of experience in the field of information security with expertise in application security, vulnerability assessments, and automation. I have been delivering the DevSecOps course at various international forums as well. Very recently, we went ahead and delivered the DevSecOps course at OWASP, which was a fully online course that happened in December 2021. And now let's go ahead and discuss what actually the delegates gain from attending our two-day course on DevSecOps. So the whole idea behind going ahead and performing or attending the training is that at the end of the 2 days, the delegates should be able to go ahead and understand how they can go ahead and tackle the different security issues like identifying trivial bugs like SQL injection or cross-site scripting, and how they can go ahead and fix that. Next, how they can go ahead and automate the different security concepts like penetration testing and identifying dependency related issues and source code related issues by injecting security in the CI/CD pipeline, and also to go ahead and understand how important role culture plays when it comes to implementation of DevSecOps within an environment. And that is done by going ahead and enabling something called as a security champion, or going ahead and changing the cultural mindset of your developers and security personnel. And finally, the whole objective of our course is to actually go ahead and identify and fix bugs early as possible in the SDLC cycle by going ahead and automating and integrating different security tools to build a secure infrastructure and a secure code, thereby going ahead and having a continuous delivery platform that's securely made. Now, let's go ahead and quickly discuss on what is the agenda that we are going to go ahead and discuss for the next 1 hour. So we are going to go ahead and understand what exactly is DevOps. We'll go ahead and understand what is DevSecOps, and we answer the 3 basic questions of what, why, and how do we go ahead and perform DevSecOps. Then we go ahead and discuss about what are the different security tools that we can go ahead and integrate in our DevOps pipeline. We then go ahead and look at a list of different tools that we actually go ahead and integrate in our two-day course. And then we'll also go ahead and look at some sample implementations and the cultural aspects of DevSecOps. Now, before we proceed with the webinar, a quick disclaimer. Now, DevSecOps majorly revolves around implementation of tools and integration of different tools. Now, please understand that we do not go ahead and endorse any specific tool that we have used within our training. And any tool that we are going ahead and discussing, or we are going ahead and integrating as a part of our two-day training, it's not an exhaustive list. We also go ahead and provide the alternatives that are present. The main focus that we have gone ahead and given in our training is to go ahead and use open source tools. So our entire two-day course is based on open source tools and technologies which we have used to go ahead and perform or to create our DevSecOps lab. The next specific disclaimer is that DevSecOps is not something that you can just pick off the shelf and start using it within your own environment. Every implementation is different and every environment is different, and that is where we would highly recommend each and everyone to ensure that any ideas they go ahead and pick up from our training, they go ahead and test it and validate it before going ahead and implementing in their production or in their client networks. Now, let's go ahead and discuss what exactly is DevOps. So basically, DevOps revolves around four different pillars, which is continuous integration, continuous delivery, infrastructure as code, and continuous monitoring. Now, let's go ahead and dig down deeper to understand each of these terms in further details. Now, in continuous integration, we actually have different developers. We actually have multiple developers who are going ahead and checking in their code into a single repository. So basically, every developer is going ahead and checking in his part of the code, and the code is going ahead and getting continuously integrated without any manual intervention. And once you have such a kind of a setup, it is called continuous integration. Now, once the code has been continuously integrated, we go ahead and move on to continuous delivery. So in continuous delivery, we have tools such as Jenkins, Circle CI, Travis CI, which basically go ahead and pull the source code from the socket repository, and they go ahead and perform two actions. So what are the two actions? So the first action that it does is it goes ahead and creates a build file or an artifact file, like a WAR file or a jar file or a zip file, depending on what the environment is. And the next action that it performs is deploying of the created artifact. Now, one question that we generally go ahead and get in our training is, where will Jenkins go ahead and deploy this artifact? So deploying the artifact in a static system, that is like a web server that has been set up on a virtual machine or has been manually configured. If you're going ahead and following such a practice, then you're totally not going ahead and doing DevOps. In DevOps, all the infrastructure that you have, which is the web servers, the database servers, or the different servers that you have, it has to be spun up using simple lines of code. And so the whole idea behind infrastructure as code is to go ahead and eliminate those lengthy configuration files, which an administrator used to go ahead and use to provision a system. Now, one of the most widely used tools in infrastructure as code is Docker, which we will be going ahead and using heavily in our two-day training. So Jenkins basically goes ahead and bundles the entire application and creates a Docker image of that particular application. So let's say we have a Java-based application, and Jenkins will go ahead and create a WAR file, and it will also go ahead and create a Docker image of that particular Tomcat container, which will hold the WAR file, and then it will go ahead and push that particular WAR file into the public or private repositories, from where it will go ahead and get executed by a Docker host into either staging or production applications. So by going ahead and using infrastructure as code, we are able to go ahead and deploy our applications into our staging and production environment. Now, We have gone ahead and discussed on how using infrastructure as code, how using continuous delivery, we are able to go ahead and provision our applications. And this gives us a fair bit of idea that DevOps is actually a fast-paced environment. Now, in such a fast-paced environment, what if there is an issue that gets identified within your infrastructure or within your application? Now, you cannot really have your operations team or your administrator going ahead and doing an SSH into the system and probably firing commands like tail-f to go ahead and see the recent logs. No, in DevOps, you actually need to go ahead and have a real-time view of your logs to go ahead and understand what are the different or what is the issue that has occurred. And to go ahead and do that, we actually go ahead and use in continuous monitoring a very famous LSTAT, which stands for FileBeats, Elasticsearch, Logstash, and Kibana. Now, the combination of these four technologies actually helps us in going ahead and aggregating the logs, visualizing the logs, and also alerting if there are any suspicious or problematic issues to the respective stakeholders. So this is the sample implementation of our DevOps lab that we will go ahead and create as a part of our two-day training at the very initial stages of our two-day training, which is the first half. We actually go ahead and create this entire DevOps lab. And in this DevOps lab, we actually go ahead and see that there is a developer who will go ahead and check in his code into a central repository, and from there Jenkins will go ahead and pick the changes, and Jenkins will go ahead and perform the two actions, which is creation of the artifact and pushing that artifact into the artifact repository, and the second action is creation of the Docker images and pushing it into the Docker registry, and the staging and the production host will then go ahead and pull the latest Docker images and deploy our applications. Now, in the production host, we also have our FileBeats configured that will go ahead and read all the different logs that are going ahead and getting generated, and it will go ahead and push it onto Logstash, from where the logs are then going ahead and getting passed into a readable format and sent to Elasticsearch. And finally, we have a GUI-based Kibana dashboard that can be used to go ahead and understand the different logs and also create different charts to go ahead and identify important data within these logs. Now, the complete operation that will be performed in our DevOps lab, from the developer going ahead and checking in his code into the continuous repository to the application going ahead and getting deployed into the staging and the production environment. Everything is happening in an automated fashion, and in such an organization where the setup, where this kind of a setup is present, the builds are going ahead and getting rapidly generated, and the changes are going ahead and getting pushed out into the production environment, probably every hour to even every minute. So what are the challenges that the security team faces in such a fast-paced DevOps environment? So we already know that since DevOps is fast-paced and there are changes that are going ahead and getting deployed every hour or probably every minute. In such an environment, it is actually a very big challenge for the security team to go ahead and test and validate and ensure that each build that is going ahead and moving into the production is free from security bugs. Now, so one of the major concerns when it comes to security in DevOps is the rapid deployment and the rapid developments that is happening. Next, we go ahead and speak in terms of scalability. And in terms of scalability, we also speak about one of the major issues, which is manpower. Now, to be true, we have always seen that in case of manpower, when it comes to DevOps, there's always a 10:1 ratio that is being considered, wherein if there are 10 or 20 developers that are present within an organization, there is only one security guy managing them. And here we are actually going ahead and talking about just one single application. In robust organizations, there are more than 50 or probably 100 different applications, and there are more than thousands of different builds that are going ahead and getting continuously pushed onto the internet. So here you actually cannot go ahead and have your security team working as a gatekeeper to go ahead and ensure that each setup is tested. You need an automated approach. And in case of DevOps, what happens is that the surface or the attack surface has also gone ahead and got increased. Now, very recently, we were actually going ahead and performing a red team assessment. And in that red team assessment, we actually went ahead and identified uh, a Jenkins instance. Now, using this Jenkins instance, we were practically able to go ahead and gain access to more than 300 different applications that were configured through Jenkins. So the attack surface has also now evolved, and the security team needs to be aware of them as well. Next, the one thing that lacks among the DevOps environment is the skill set, because in DevOps environment, our devs can no longer go ahead and say that, hey, I do not know how to go ahead and push the applications into the production, or the operations guys, they actually cannot go ahead and say that, hey, I do not know how to read code. The skill set that is required in case of a robust DevOps environment is quite high. And when it comes to security, the dev and the op guys now also need to go ahead and understand what are the different security issues and what are the different vulnerabilities that might be affecting their code or that might be affecting their system. So generally, in such an environment, we see cases where the security team is approached by the application team or the business owner, probably on a Wednesday evening or a Thursday evening, saying that, hey, my application is supposed to go live on Monday. Can you quickly go ahead and do a security test and go ahead and give me a report so that I can go ahead and publish my application, or I can go ahead and deploy my application. Now, the security team actually has to go ahead and perform different checks, like it has to perform source code review, it has to perform dependency check, it has to go ahead and perform compliance review, it has to go ahead and look at what are the code level issues, it has to look at the vulnerable dependencies. Now, security being treated as a game, security being treated as an afterthought is one of the major challenges that is faced when it comes to a DevOps environment. And what if, or the major problem in this kind of an approach is, what if there is one single SQL injection that gets identified, right? And if that SQL injection is identified by the researcher, the cost to go ahead and fix that both is heavy when it comes to the money and also the time that will be required to go ahead and fix that issue. And hence, it is a lot more advisable to go ahead and follow the shift left approach, where we go ahead and move security testing at the initial phases of the development. So, taking a very good example, even the most simplest open source security scanning tools or automated source code review tools, once pushed into the CI/CD pipeline, will actually go ahead and help you in discovering trivial SQL injection bugs and cross-site scripting bugs, which you can go ahead and identify and fix even before the application has been deployed into the staging and the production environment. And that is where the shift left approach is one that will go ahead and help you in identifying these issues a lot more earlier and a lot more easier, thereby going ahead and ensuring that you have a cleaner code pushed into the staging and the production environment. Now, what if you go ahead and move the entire umbrella of security testing, that is the automated source code review, the compliance review, the dependency check, everything gets performed even before your application is moved into the production environment. And if you go ahead and follow this kind of an approach, if you go ahead and use the shift left approach, what you go ahead and achieve at the end of this particular approach is known as DevSecOps. So what exactly is DevSecOps? DevSecOps basically revolves around integration of multiple security tools like this security automated source code review, or going ahead and doing your software composition analysis or dynamic analysis, container scanning, or vulnerability assessment. And that can be achieved by going ahead and using security as a code culture, where you have an automated system in place which will help you in going ahead and identifying these bugs in an automated manner, thereby going ahead and ensuring that you have a safer build that is pushed on into your production environment. Finally, DevSecOps is only successful when you actually go ahead and promote cross-skilling, which means that you have appropriate training sessions being done, you have your developers being educated at regular intervals on security related topics so that they can go ahead and understand what exactly are the security vulnerabilities and the different issues that might be affecting their systems or applications. So why do we actually require DevSecOps? So all the different challenges related to rapid deployments, rapid developments that are faced by the security team in a DevOps environment, all the different scalability related issues are actually addressed if you go ahead and start practicing DevSecOps. Now, one question that we always receive is, when do you actually go ahead and achieve something called as a secure by default environment? When does it happen in DevSecOps? So secure by default environment is something that you cannot go ahead and start achieving probably 1 or 2 months after you start practicing DevSecOps. No, for going ahead and attaining a secure by default environment, you actually need more than 14 to 16 or probably some at times more than 2 years, wherein you have appropriate tools being integrated, you have a very good feedback mechanism that is being passed on to the developers. And by using this feedback, the developers are able to go ahead and make changes. They are able to go ahead and code securely and identify issues at the very early stages of the development life cycle. And once all of this starts happening, you actually go ahead and achieve something called as a secure by default environment. All right, so now that we have gone ahead and discussed why we require DevSecOps, let's discuss how are we going ahead and performing DevSecOps. So the very first thing that we are going ahead and doing is we are going ahead and starting at the developer's workstation. We go ahead and install what is called as a pre-commit hook. Now, you guys must have gone ahead and heard about a lot of breaches where sensitive information like tokens, keys, passwords, etc. were leaked out into the public repository. Now, one question that arises is, how can we go ahead and avoid such breaches? How can we go ahead and avoid sensitive information getting leaked out into the public forum or public repositories? And that is where we can go ahead and use pre-commit hooks. And what pre-commit hooks basically do is they go ahead and perform a regex-based check whenever there is a developer going ahead and performing a checking of their code or going ahead and committing or pushing the code. The regex will go ahead and get activated, and the regex will check if there is any sensitive information like passwords, AWS keys, session tokens, or any sensitive information as such is going ahead and getting uploaded. And once it identifies it, it will go ahead and stop that commit from happening, and will go ahead and provide an error message and a report to the developer saying that this particular sensitive information was getting committed. And one such tool to go ahead and help you identify such sensitive information at the developer's workstation is Talisman. We will be going ahead and integrating Talisman as a part of our 2-day training, where each and every delegate will go ahead and integrate Talisman and understand the rules and also perform hands-on exercises to see how Talisman can be used to go ahead and prevent such sensitive information disclosures. Now, once we have gone ahead and looked at sensitive information going ahead and getting disclosed, the next thing that we are going to look at is secrets management. Now, in DevOps environment, you will never go ahead and see that the entire pipeline is being halted for the administrator to go ahead and put the credentials for going ahead and deploying your applications. No, in DevOps, everything has to be in an automated fashion, or everything has to happen in an automated fashion. So the question that arises is, where are the credentials getting stored in a DevOps environment? The credentials are either stored in configuration files or are stored as environment variables in a DevOps culture. But these credentials are usually stored in clear text, which is a very, very big issue when it comes to security. Because if there is any compromise that happens, even of your Docker system or of the configuration files or even your environment variable, everything gets easily exposed. So the solution that we have over here in going ahead and using a DevSecOps environment is going ahead and implementing a secrets management solution. Now, what does this secrets management solution do? So basically, it will go ahead and tokenize your credentials. It will go ahead and convert your credentials into a set of tokens, which can then be given to your developers to go ahead and put it in their code. And whenever you have continuous delivery tools like Jenkins, which will go ahead and build your code and deploy it into your production environment, Jenkins will go ahead and use these tokens to finally go ahead and provision your application. And this is how you can actually go ahead and prevent exposures, or you can actually go ahead and do a very safe and a secure way of secrets management within your environment. And one such tool that can help us in going ahead and performing a safe and a secure secrets management is Hashicorp Vault. And this is a tool that we'll be going ahead and integrating in our two-day lab as well. Now, it is basically a Go binary, which can be very easily set up. Now, one good question that we usually get in our trainings is, what if our token gets compromised, right? What happens if the tokens that we are going ahead and using, what if it goes and gets compromised? Will it go ahead and lead to credential disclosure? So the whole or the basic premises on how the secrets management tool should be deployed is that the vault should not be accessible to your developers, and the vault server should actually be accessible to the administrator only, who will have access to go ahead and perform the key generation. And this will be more of a controlled access with appropriate segregations in place to prevent any such misuses or any such compromises from happening. So the whole idea behind going ahead and using the secrets management or the Hashicorp Vault is that your administrators will not have access to the code and your developers do not have access to secrets. And that is where the lesser number of people who have access to the secrets, the lesser the chance of your secrets going ahead and getting exposed. And that is the principle that is used by Hashicorp. Now, once we have gone ahead and secured our secrets, we now go ahead and move on to the next section. So until now, the developers have gone ahead and checked in their code, and we have some level of assurity that our source code is not leaking any sensitive information and the secrets are stored in a safe and a secure way. But what if the source code that is present, or what if the code that we have, it contains a vulnerable library? So for example, what if your application is using a struts to web framework of Java? Now you have developed or you have gone ahead and coded a very good application which does not have any cross-site scripting or SQL injection vulnerability. But what if there is a struts to vulnerability in the framework that you are using? And this is a very good example, or this is something that has actually happened with Equifax as well. So if someone is aware about the Equifax attack, they'll be able to relate it, right? So what happened in case of Equifax was that they were using a struts2 framework, which had a remote code execution vulnerability. And this makes it very important or extremely important that you go ahead and you're aware of what are the different artifacts and what are the different libraries that you're going ahead and using. And by going ahead and running a software composition analysis tool, you can actually go ahead and check if any of these vulnerable dependencies are present within your code. And by going ahead and using these tools, you can actually go ahead and execute them directly by Jenkins itself. So Jenkins will go ahead and execute these tools, and it will identify if there are any high or critical vulnerabilities. And you can go ahead and customize your Jenkins script to actually go ahead and fail your builds. And one such tool that can help us in performing software composition analysis is dependency check. Dependency check is a Java-based tool that you can actually go ahead and use to go ahead and analyze the different vulnerable dependencies that are present. And in our two-day training, we actually go ahead and integrate and use dependency check to identify the different vulnerabilities that are affecting our frameworks and libraries. And we also go ahead and remediate them. Once we have looked at the dependencies, we now move on to static analysis security testing. So basically, we have checked for the vulnerable dependencies. But what about the source code? What if my junior developer is following a bad security practice and has put a code which leads to an SQL injection vulnerability? What do you do about that? So after going ahead and performing a dependency check, we can actually go ahead and run a static analysis security testing tool. And this tool can also be executed by Jenkins directly. And the most basic tools are very much capable of identifying the different low-hanging fruits, such as cross-site scripting and SQL injection vulnerabilities. And one such tool that we are going ahead and integrating as a part of our lab is FindSecBugs. FindSecBugs will go ahead and help us in identifying the different vulnerabilities affecting our Java-based code. And it is recommended that you go ahead and integrate these tools at the very early stages of your development so that your applications are safe even before it has moved on to the staging or the production environment. Next, we go ahead and look at dynamic analysis security testing. Now, once my staging environment is set up, and now I wish to go ahead and perform dynamic analysis using tools like OWASP. So ZAP is basically an open source tool which has a very rich API interface where you can go ahead and provide the different URLs and the cookies and the credentials using which ZAP can be automatically executed, and the API of the ZAP can also be directly executed to Jenkins itself. So if we go ahead and see this figure, once our application is live and up and running into our staging environment, we can go ahead and start the execution of our dash tool. Now, one question that arises is why are we going ahead and performing this dynamic analysis when we have already gone ahead and performed static analysis to identify the different issues in our code? So dynamic analysis is actually a runtime vulnerability analysis, which will go ahead and identify the different issues once the application is up and running. Also, a combination of your dynamic analysis security testing and static analysis will help you in weeding out the false positives that might be identified by either of the tools. And this is how you can actually go ahead and improve the overall implementation of your security tools when it comes to DAST and SAST. And OWASP is the tool that will actually go ahead and integrate as a part of our training once you go ahead and start, or once you go ahead and enroll to our course. Next, look at vulnerability assessment. Now the next thing that we need to go ahead and do is perform vulnerability assessment, and we have gone ahead and checked the application in the running phase. And now we need to go ahead and see if our application is actually running on an insecure port, or if there is any vulnerable service that is present on the infrastructure where our application is hosted. So here we have tools like OpenVAS, Qualys, Nessus, which can go ahead and perform a scan and can help us in going ahead and identifying the vulnerabilities. One such tool that we are going ahead and integrating as a part of our CI/CD pipeline, as a part of our two-day course, is OpenVAS. Now, OpenVAS has an excellent CLI interface using which you can actually go ahead and perform, or you can actually go ahead and just provide a domain name or the IP address of that machine, and we'll go ahead and scan that particular domain or scan that particular IP and spool out the different vulnerabilities. Next, we move on to compliance as code. So under compliance as code, we actually go ahead and look, or we actually move on to the live stage of our environment, wherein once our application is live and in production, we would want to go ahead and check if we are meeting the compliance standards such as HIPAA or PCI DSS, etc., depending on different configurations. And the application, it should go ahead and run, right? So one of the most important configurations is that your application should not be running as with root privileges. Now, a lot of developers today, they go ahead and create these Docker images and they go ahead and execute these Docker images with root privileges, thereby going ahead and finally running the application with root privilege, thereby going ahead and violating a lot of compliances and security best practices. And this is where we can use tools like inspect, which can help us in going ahead and creating very simple Ruby-based files where you can go ahead and codify the entire checks that need to be performed for compliance. And by going ahead and hooking the inspects onto your Docker container, you can go ahead and run and execute the scans. You can go ahead and execute the Ruby script, and it will go ahead and identify the different compliance status of the Docker containers that you're running, thereby going ahead and helping you maintain a safe state of your infrastructure as well. As a part of our two-day training, we go ahead and integrate inspect in our lab, and we also go ahead and see the results of the different compliance aspects related to CIAS benchmarks in our lab. Next, we have container scanning. So the next thing that we would want to go ahead and do is perform container scanning, since a lot of different developers directly go ahead and pull the Docker images from the Docker Hub or open source libraries. And we do not want the security posture, or probably we don't know the security posture of these different open source repositories, whether they have a malware that has been embedded inside it, or what are the vulnerabilities that are present inside it. And this is where we will go ahead and use our container scanning tool, which is Trivy. Trivy will actually go ahead and execute the scan directly on the Docker registry, and it will go ahead and spool out the different vulnerabilities that is affecting my Dockers that are present. Next, we discuss about vulnerability management. Now, vulnerability management lies at the heart of DevSecOps, since all of these different security tools that are present that we have discussed till now, such as dependency check, overlap, find side bugs, Trivy, inspect, will actually go ahead and generate a lot of different vulnerability data in different shapes, different formats, and different sizes. And if you go ahead and give these reports directly to the developers, they might not be able to go ahead and understand the context of it. And hence, it is extremely important to go ahead and normalize this data, store it into one particular location. And the one tool that can help you go ahead and do this is ArcherySec. Now, in our lab as well, we have integrated ArcherySec, using which we actually go ahead and create nice dashboards, nice data formats or data charts that can help developers understand the issues that are affecting their applications, and also go ahead and create context out of it. Next, we actually go ahead and look at the security incident or continuous monitoring now. And till now, we actually have a certain level of assurance that we do not have any SQL injection, cross-site scripting, our containers are safe, and libraries that we are using are fine. But what happens, or what will happen, if we actually go ahead and identify that we actually have a vulnerable instance of SQL injection that is present, which is actually a 0-day. We would still want to go ahead and stop that. We would still want to go ahead and prevent an attacker going ahead and exploiting it on our application. And this is where we go ahead and bring our security incident and response tool, which is Mod Security WAF. Now, Mod Security WAF is actually an open source WAF, which we will actually go ahead and configure in our 2-day DevSecOps training. And by configuring this particular WAF, we'll be able to go ahead and prevent such attacks from going ahead and targeting our web applications. So this is the entire lab that we have gone ahead and created. These are the different stages that we have gone ahead and integrated. So we have the pre-commit hooks, we have secrets management being done, we have software composition analysis, static analysis, security testing, at the infrastructures, we have vulnerability assessment, dynamic analysis being done, container scanning being done, and we also have the very famous stealth stack that will help us in identifying the different issues in our logs as well. And this is the entire DevSecOps lab that we have created in Java, which each and every delegate will have a personalized access to. Each delegate will be provided with their own browser-based lab, which they can go ahead and use for the next 2 days. They can go ahead and practice, they can go ahead and integrate and follow the trainer and go ahead and understand the different aspects of DevSecOps. Now, I actually have a very interesting video that will go ahead and help you understand our entire 2-day lab in action. That will go ahead and give you a very small gist and summary of the entire 2-day course that we have. So allow me to go ahead and play this video so that you can go ahead and understand it further. Right, so as I said, it's our entire 2-day lab is actually based on a browser-based lab, wherein all you need is just a web browser to go ahead and attend our training. So it's a 2-day hands-on training that we have, wherein we will go ahead and integrate security to go ahead and automate the different open source tools that are present to go ahead and perform DevSecOps. Now we have a very nice playbook based guide that will be provided to each and every delegate, where the delegates will go ahead and use this playbook to go ahead and configure the lab and also go ahead and perform the different exercises, and will go ahead and perform the different integrations of the tools as well. So each stage, the developers will go ahead and use this. We have a browser-based IDE as well that will be used by the delegates to go ahead and look at the entire code. They can make changes to the code and start integrating security in the DevOps pipeline. Right, so this is the DevOps pipeline. At stage 1, we will integrate SAST, stage 2, DAST, stage 3, container scanning, and stage 4, we will go ahead and integrate the WAF. So at the very initial stages of our training, once this training starts on day 1, we'll actually go ahead and build our DevOps pipeline, wherein we will go ahead and look how a fast-paced DevOps environment works, wherein just by going ahead and using a single command, we will see how using the power of DevOps, we can deploy our applications into the production and staging environment with just one single click. Finally, at the end of the day 2 of our course, you'll see that we would have integrated the different security tools in our different security stages, like the static analysis stage, the dynamic analysis stage, and the container analysis stage. And finally, we will configure our WAF as well to go ahead and automate the entire security aspects in our CI/CD pipeline, thereby leading to DevSecOps. Right, so this is an introduction of our pre-commit hook tool, which is Talisman, where you'll see that as soon as a developer commits sensitive information, it will go ahead and detect that particular sensitive data, and it will prevent that sensitive information from going ahead and getting committed. Next, we have software composition analysis. We can go ahead and run, and we can see that there are different vulnerabilities identified in our code, and the pipeline will go ahead and fail because of the high number of issues. We will mitigate these issues, and then we'll go ahead and push the fixed version of the code in our lab, thereby going ahead and identifying the vulnerabilities and also identifying how you can fix the majority of the issues using dependency check scanner. Right, so by going ahead and fixing this, we are able to go ahead and move further, which is static analysis. And under static analysis, we actually go ahead and look at the different issues that might be affecting it, and then we go ahead and fix them as well. And once we go ahead and fix them, we now are comfortable in understanding that even our source code is secure, So each delegate will actually go ahead and make the changes in the code, understand why this vulnerability has occurred and how it can be fixed, and then rerun the SAST, rerun the secure code tool to go ahead and identify if the issues are fixed and if we have gone ahead and moved a safe version of the code. Next, we have DAST. We have WhatsApp that will help us in identifying the runtime issues within our code and within our application. And once the dash stage has completed, it will go ahead and spool out the different vulnerabilities. Similarly, we will perform container scanning with Trivy, where by going ahead and identifying the different containers that we have, we'll go ahead and perform a live scan, and we will go ahead and look at the different vulnerabilities that are affecting our containers. Finally, we have the compliance scan done using inspect. We will use the CIS benchmark to identify the rules. We will go ahead and check. We'll go ahead and actually configure rules, and we'll see if it is if our containers, if our infrastructure is compliant or not. And we can also go ahead and make changes and rerun the rules, thereby allowing everyone to have hands-on exercises using our compliance scanning tool system. Finally, we have the WAF deployment, where we'll go ahead and look at real-time examples on how WAF will be able to prevent such malicious input from getting submitted, and we'll be able to use the Kibana to go ahead and generate nice charts and dashboards to identify the different attacks that are targeted. And we'll see the implementation of our ArcherySec tool, which is a vulnerability management tool, to look at the different vulnerabilities identified over the 2 days in our different security tools. Right, so this was a very quick gist of the entire 2-day training that we have. And these are the different tools of trade that you can go ahead and use. So we have actually gone ahead and used open source tools. As I said, we are not going ahead and recommending any particular tool, right? Or we are not going ahead and saying that this is the only tool that is present. For every tool that we will discuss as a part of our 2-day training, we will ensure that we go ahead and provide the appropriate alternatives for that tool as well, which you can go ahead and use. The whole idea is that we have given preference to open source tools, and we do not endorse or we do not go ahead and recommend any specific tool. Right, so here we have also gone ahead and provided the different tools for vulnerability management, dynamic analysis, compliance as code, and WAF. So as I said, we are going ahead and using inspect as our compliance as code tool. We also go ahead and help delegates understand what are the alternatives, like you can use Kitchen CI or Docker Bench for security if it works well in your environment. Now, one question that arises over here is, does programming language matter when it comes to DevSecOps? The answer to that is yes. Programming language matters, but only in 2 stages, which is your software composition analysis and static analysis security stage, because these are the only 2 stages that are dependent on the programming languages that you're using. And there are different tools that actually go ahead and support only one particular language, thereby making it harder for you to have one single tool to go ahead and perform scans on different languages. There are some exceptions like SonarQube that actually go ahead and support different languages, but the majority of the tools that are present, they actually go ahead and focus on one particular language. So just give you a gist or a summary of that. We actually have gone ahead and curated the list. So probably if you have a Java-based lab or Java-based code, we can use dependency check as your software composition analysis, and source code analysis can be done by SonarQube or FindSecBugs. Similarly, you have different tools for Python, PHP, .NET, Ruby, and Node.js that you can use. Right. So if you want to go ahead and recreate the entire DevSecOps pipeline in Ruby. So since our entire DevSecOps pipeline is in Java, if you want to go ahead and recreate the same in Ruby, all you need to do is just change two tools or go ahead and modify two tools, which is instead of dependency check, you can go ahead and use uh, bundle audit, and you can use Brakeman to go ahead and perform secure code review to go ahead and identify the different bugs. Similarly, for PHP, you can use Sensio Lab Security Checker and PHP CS Security as your SCN SaaS tool, and all other tools that are integrated as a part of our two-day course will still remain same. Similarly, for Python, only two tools change, which is the SaaS tool and the SCA tool. All other tools, which is the CI/CD tools, the dynamic scanning tools, the container scanning tools, and the WAF will remain the same. And similarly, for Node.js, you can use Node.js scan and npm check for SAST and SCA, and all the other tools will still remain the same. Now, when it comes to DevSecOps, everyone feels that if I go ahead and integrate the security tools, I'll be able to go ahead and reap the benefits of DevSecOps. That's not true. When it comes to DevSecOps, one of the major influential aspects is the cultural aspect. Now, if you want to go ahead and compare a percentage, it's more of 60% culture and 40% of tools integration, because automation alone will not solve the problems. You need people who go ahead and have a collaborative mindset, who want to go ahead and identify the different steps that can be taken, identify the different aspects that can help them in raising the overall security posture of your organization. And you need people who have security mindset outside of your security team, wherein the whole idea behind this cultural aspect is that everyone is responsible for security. It's not just a security team. And the whole idea is to avoid the blame game and for the security team to actually go ahead and create security champions that will eliminate the need of having a security dedicated team. And there is one single person that is present in every team that will help in security aspects. These are some references if you're interested in understanding how exactly the DevSecOps works and what are the best practices related to DevSecOps. Now, what are the different key takeaways from our course? So one key takeaway is we go ahead and ensure that every delegate understands that security is everyone's responsibility, not just the security team's responsibility, right? If there is a SQL injection that is present over the internet, it's not just the security team who has missed it, but it's also the junior developer's responsibility who has gone ahead and added that particular code. Similarly, you need to go ahead and move security as an integral part of process, not just a gatekeeper. The whole idea behind our training is to help people understand that security is there to go ahead and help and prevent security issues, and not someone who is there to just pick and identify issues and stop your deployments from going ahead and proceeding. We are there to help you increase the overall security of your applications so that any further issues could be avoided. And last but not the least, we go ahead and emphasize on the fact that DevSecOps is not one size fits all. Depending on what your requirement is, depending on what your coverage is, your mileage will vary, your implementations will vary. So the whole idea is start small, start integrating one or two security tools, see the benefits, see the advantage, and then move further. These are some further training dates that we have. So if you are interested in our course, these are the dates where we are going ahead and delivering our trainings, both in UK and USA time zones. And we also have other courses wherein we have the AppSec course for UK and the Hacking and Security Cloud course, both for UK and USA, that will be delivering in the next month. And these are some upcoming webinars if you are interested in going ahead and looking at what are the different courses that we are running. And if you want to go ahead and understand about them, I would highly recommend you to go ahead and set on these webinars and gain a further understanding. And this is where I pass it on to John to go ahead and discuss on the webinar price.
Thank you, Abhijay. Before we get into Q&A, as previously mentioned, this webinar is a precursor to our 2-day DevSecOps training course. As a special bonus for attending this webinar, just by speaking to one of our team members about your training or pen test requirements, you can become eligible to win a free place on our next live remote delivery DevSecOps course. To arrange your call and gain entry to the prize draw, just email us at contact@notsosecure.com. As a reminder, we teach, we hack. If you're in need for or have future need for cybersecurity risk assessments, we'd be super grateful for the opportunity to perform a risk assessment on your behalf. We look forward to speaking with you in the near future. Thank you. We now open it up for Q&A. Please use chat to ask your questions. First question, I'm gonna hand it over to Ryan.
Yeah, thank you for that, John, and thank you, Abhijay, for that presentation. You both provided information I think is very important, obviously, about Claranet as well as the actual webinar itself. So as John just mentioned, we do have a live Q&A section, and we've had a couple of questions come in already. But if you do have any more questions, please feel free to put them in, and we'll try and get them through. Try and get through them in the next couple of minutes. So Abhijay, the first question we've had in is: does the training involve any paid security tools integration?
Right. So as I have already discussed, the entire lab that we have gone ahead and created, the entire context of our lab is that we have not gone ahead and endorsed any tool. We have not gone ahead and used any specific paid tool. The whole idea is to go ahead and use the tool that has worked well for us. We have given preference to open source tools. We have gone ahead and used open source tools within our lab, and we are using open source tools for integration of the security tools as well. And we do not recommend or we do not endorse any tool within our class as well. And that is where, if you're interested, we actually have devised the entire lab based on open source content.
Perfect, thank you for that. Another question we've had is there any dependency on programming language related to the actual training?
Right, so when it comes to dependencies on the actual training, so our class is actually platform agnostic, because there is a SQL injection that is present in our code. It's pretty similar to anything that is present in Java or PHP. Majority of the tools that we have focused is around Java, but you can go ahead and see that I've already provided you an explanation that only 2 different stages are dependent on the language, which is your software composition analysis and static analysis security testing. Apart from the tools that are implemented for these 2 stages, all other tools are the same and can be used on various different languages. And in our training, we'll ensure to go ahead and help you understand what are the alternatives to our SAST and SCA tool, so that you can go ahead and understand the different tools on your specific languages as well.
Great, thank you for that. That is all the questions we've had in today. If you do have any more questions either later on today or tomorrow, please do reach out to us. We will be happy to answer that questions or any other questions related to Claranet or anything we can do for you in general. As the webinar ends in about a minute or so, there will be a quick survey at the end. Only a couple of questions just related to the webinar and future webinars and training courses we are running, so we'd be delighted if you could fill that out for us, please. And yeah, thank you again to Abhijay, and thank you to John for all the information provided there. I hope everyone has a really good rest of the day and rest of the week, and thank you for joining. We hope to see you on the webinars in May and June and July. Thank you for that.